Welcome to K.S. Max Tuition. Today we discuss new topic Laplace transform. Laplace transform. What do you mean by Laplace transform? If definition Laplace transform. If f of t be a function, f of t be a function defined that f of t be a function defined for all t greater than or equal to 0. Let f of t be a function defined for all t greater than or equal to 0. Let f of t be a function defined for all t greater than or equal to 0. Then the Laplace of f of t is defined as Laplace of f of t is defined as Laplace of f of t equal to integral 0 to infinity e raised to minus st f of t dt. If f of t be a function defined for all t greater than or equal to 0, then the Laplace of f of t is defined as Laplace of f of t equal to integral 0 to infinity e raised to minus st f of t dt. Or we can write, instead of Laplace of f of t means we can write phi of s. Laplace of f of t equal to phi of s equal to integral 0 to infinity e raised to minus st f of t dt. That is, you have to remember this point. Phi of s is equal to integral 0 to infinity e raised to minus st f of t dt. Okay, that is the definition. Alright. Yes, we can do some basic formula connecting about Laplace transform. That is also important formula. First, yes, tell me, prove that. Prove that.
Laplace of 1 equals to 1 by s.
Yes. That is also basic formula. Laplace of 1 is always equal to 1 base. We can prove this. Prove. See, by the definition of a Laplace of f of t equal to Laplace of f of t equal to integral 0 to infinity e raised to minus st f of t dt. Here f of t means 1. So Laplace of 1 equal to integral 0 to infinity e raised to minus st into 1 dt. That means integral of this point e raised to minus st means e raised to minus st by minus s, limit 0 to infinity. Okay. Equal to minus 1 by s out of e raised to minus infinity minus e raised to 0. The value of e raised to minus infinity equal to 0 and e raised to 0 equal to 1. That is minus 1 by s out of 0 minus 1 equal to 1 base. So we can write Laplace of 1 equal to 1 base. That is most important formula. For the you have to remember Laplace of 1 equal to 1 base. Okay. Ready? Ready? Yes. Ready? Next.
Laplace of
Yes, prove that. Laplace of
e raised to 80
e raised to 80
equal to 1 by s minus a.
Yeah. That is the second formula. We have to prove that Laplace of e raised to 80 equal to Laplace 1 by s minus a. Prove. See, by the definition of Laplace transform, we can write Laplace of f of t equal to integral 0 to infinity e raised to minus st f of t dt. That is Laplace of e raised to 80 equal to integral 0 to infinity e raised to minus st into e raised to 80 dt. Instead of f of t, I can substitute e raised to 80. A raised to m into a raised to n is equal to a raised to m plus n. So we can write e raised to minus st plus 80 into dt. take t as common term. That is integral 0 to infinity e raised to a minus s into t dt. Then this integral equal to e raised to a minus s into t divided by a minus s. Apply the limit 0 to infinity. 0 to infinity. Okay. That is equal to 1 by a minus s into e raised to a minus s into t divided by minus s. Okay. Integral with respect to t minus s. Or we can write this also, you can write a minus a common, you can take a minus s. And erase integral of e raised to 0 equal to, sorry, apply the limit. That is, apply the limit equal to e raised to a minus s into infinity, e raised a minus s into infinity minus integral e raised to 0, e raised to 0. This value equal to e raised to infinity equal to 0 and e raised to 0 is equal to 1. So we can write 1 by a minus s into integral of e raised to 0 means minus 1. This is 0, 0 minus 1, minus 1. That is minus 1 by a minus s, or you can write 1 by s minus n. Okay, so we can write Laplace of e raised to at equal to 1 by s minus n. Okay, that is the second point. Laplace of 1 equal to 1 by s, and second point, Laplace of e raised to at is equal to 1 by s minus n. Okay, second point. Then third.
Laplace of t raised to n equal to
Prove that Laplace of t raised to n is equal to
n by
n by
n factorial by s raised to n plus 1.
yes. We have to prove that. That is the third basic formula. Laplace of t raised to n is equal to n factorial by s raised to n plus 1. Okay. Here also we can write by the definition of a Laplace transform. We can write integral 0 to infinity e raised to minus st f of t dt. That is Laplace of t raised to n equal to integral 0 to infinity e raised to minus st into t raised to n dt. Okay. This is exponential form and this is algebraic form. So we can apply the integration by parts. Then 0 to infinity t raised to n into e raised to minus st dt. This is the first function and this is second function. Integration by parts. First function into integral of second minus integral of derivative of first into integral of second. That is first function t raised to n into integral of second e raised to minus st divided by minus s minus integral of derivative of first n into t raised to n minus 1 and integral of second e raised to minus st divided by minus s dt. Limit 0 to infinity, this also 0 to infinity. Okay, e raised to minus infinity 0 and e raised to 0 is equal to and e raised to 0, this e raised to minus infinity means is 0 and put n equal to t equal to 0, then this also 0. So upper limit minus lower limit equal to 0. First part is 0 minus into minus plus n by s into integral 0 to infinity t raised to n minus 1 e raised to minus st dt. That is the first part. That is n by s into integral 0 to infinity t raised to n minus 1 e raised to minus st dt. Okay. Well, Laplace of t raised to n equal to n by s into integral 0 to infinity t raised to n minus 1 e raised to minus st dt. Again we can apply the integration by parts. That is Laplace of t raised to n is equal to n by s out of first function t raised to n minus 1 into integral of second e raised to minus st divided by minus s minus integral of derivative of first n minus 1 into t raised to n minus 2 into integral of second e raised to minus st divided by minus s dt. Is it clear? No problem. Okay. Then apply the limit 0 to infinity. Okay. That is equal to n by s out of Apply this e raised to infinity minus infinity 0 and 0 is also equal to 0. First part is 0. Minus into minus plus n minus 1 by s into integral t raised to n minus 2 e raised to minus st by minus e raised to minus st divided by s into dt. Okay, minus into minus equal to plus, then n minus 1 by s into t raised to n minus 2 e raised to minus st dt. Limit 0 to infinity. So we can write n into n minus 1 by s square into 0 to infinity t raised to n minus 2 e raised to minus st dt. That is the second part of the integration. First part is equal to n by s into 0 to infinity t raised to n minus 1 e raised to minus st dt. Then again we have to integrate this portion, then we get n into n minus 1 by s square into 0 to infinity t raised to n minus 2 e raised to minus st dt. Again integrating, then we get the result, again integrating, then we get n into n minus 1, n minus 2 by x cubed into integral 0 to infinity t raised to n minus 3 e raised to minus st dt. Okay. If the process is continuing, then we can write n into n minus 1, n minus 2, etc. 3 into 2 into 1 by s raised to n. Integral 0 to infinity, this t raised to n minus n, e raised to minus st dt. If the process is continuing up to n times, then we can write this final result becomes as n into n minus 1, n minus 2, etc. 3 into 2 into 1 by s raised to n into integral 0 to infinity t raised to n minus n e raised to minus st dt. Okay, then I'm going to drop this point. Okay. Then equal to n into n minus 1, n minus 2, etc. 3 into 2 into 1 by s raised to n into t raised to n minus n t raised to 0, which is equal to 0. Integral 0 to infinity e raised to minus st dt. That is equal to n into n minus 1, n minus 2, etc. 3 into 2 into 1 by s raised to n into e raised to minus st by minus s. Limit 0 to infinity. Okay. E raised to minus st divided by minus s. So we can write n into n minus 1, n minus 2, etc. 3 into 2 into 1 by this s raised to n into s raised to n plus 1, n plus 1 into e raised to minus infinity 0, e raised to 0 1 divided by minus 1. This minus and minus cancel, then we get plus. So this final result equal to n into n minus 1, n minus 2, etc. 3 into 2 into 1 divided by s raised to n plus 1. This is equal to n factorial divided by s raised to n plus 1. Okay, so we can write Laplace of t raised to n equal to Laplace of t raised to n equal to n factorial divided by s raised to n plus 1. Okay. This portion equal to minus into minus equal to plus 0 minus n. Upper limit e raised to minus infinity 0 and e raised to 0 1 0 minus 1 minus 1. By we have already taken this s, so this becomes as s raised to n plus 1. Then 1 minus 1 is there. This minus 1 and minus 1 becomes as plus 1. So the final result equal to n into n minus 1, n minus 2, etc. 3 into 2 1 by s raised to n plus 1. This is equal to n factorial. So we can write Laplace of t raised to n equal to n factorial by s raised to n plus 1. Okay. Ready? Yes. Next.
Laplace of sin 80.
Do that. Laplace of sin 80
equal to a by s square plus a square.
A by s square plus a square. We have to prove that Laplace of sin 80 equal to a by s square plus a square. Proof. By the definition of Laplace of f of t, Laplace of f of t equal to integral 0 to infinity e raised to minus st f of t dt. Okay. Then Laplace of sine at equal to integral 0 to infinity e raised to minus st sine at dt. This we can apply this by using integration by parts. We can simplify this result. But there is one formula is there. Integral e raised to ax into sine bx dx equal to a into sine bx minus b cos bx divided by a square plus b square. We can apply this formula here. Integral e raised to x sine bx dx equal to a sine bx minus b cos bx divided by a square plus b square. So, in Laplace of sine at equal to this e raised to minus st. Here a means minus s. Okay, that is minus s sine b means a at minus b means a cos bx means cos bt divided by a square plus b square, that is equal to minus s square or minus s all square plus a square. By applying this formula, e raised to x sine bx dx is equal to a sine bx minus b cos bx divided by a square plus b square. In this case, a equal to minus s and b equal to a. So substitute that value. Instead of a means minus s, sine bx means sine at minus b means a, cos bx means cos bt divided by cos bx means cos 80. Sorry. Here b means cos 80 divided by cos 80 divided by a square plus s square. Apply the limit 0 to infinity. Okay. Into e raised to x into e raised to x into. Okay. E raised to. Here also we have to write this is equal to Laplace of sine at equal to Laplace of sine at equal to e raised to minus st into minus s sine at minus a cos 80 divided by a square plus minus s all square. E raised to x into a sine bx minus b cos bx by a square plus b square. Apply the limit. E raised to this 1 by a square plus a square is constant. We can take outside s square. E raised to minus infinity 0 minus e raised 0 1 sine 0 0 cos 0 1, that is 0 minus cos 0 means 1 minus 1. E raised to minus infinity 0, that means this whole terms becomes a 0. And apply the 0, e raised 0 1 1 into sine 0 0 1 into 0 minus cos 0 1 minus a into 1. Okay. Minus a into 1. Cos 0 means 1. So we can write minus a into. Okay. Minus into minus plus. So we can write this result equal to a by s square plus a square. So the Laplace of sine at equal to Laplace of sine at equal to a divided by s square plus a square. Okay. Ready? Yes.
Laplace of cos 80 equal to s by s square plus a square.
Yes. Next formula. Prove that Laplace of cos 80 equal to s by s square plus s square. Okay. S by s square plus s square. That is, by the definition of a Laplace transform, we can write Laplace of f of t equal to integral 0 to infinity e raised to minus st f of t dt. So, Laplace of cos 80 equal to integral 0 to infinity e raised to minus st cos 80 dt. Okay. Here also we can apply one formula. Integral e raised to x cos bx dx equal to integral of e raised to ax cos bx dx equal to e raised to x into a sin b a cos bx plus b sin bx divided by a square plus b square. Okay. Integral of e raised to x cos bx dx equal to e raised to x into a cos bx plus b sin bx divided by a square plus b square. Here a means minus s. Here a equal to minus s, b equal to a. So substitute that value here. Laplace of cos at equal to e raised to minus st into a means minus s. Cos bx means cos at plus b means a. Sin bx means sin 80 divided by a means minus s the whole square plus b means a square. Limit 0 to infinity. Then also we can write this is equal to 1 by a square plus s square out of e raised to minus infinity 0 minus e raised 0 1 cos 0 1 minus s into 1 sin 0 is equal to 0. Okay, minus into minus plus. So we can write s by s square plus a square. So Laplace of cos at equal to s divided by s square plus a square. Okay. Yes. One more question, sir. Sin h at. Or do one thing. Tell me.
Prove that
Prove that.
Laplace of sin h at
Laplace of sin h at equal to
a by s square minus a square.
a by s square minus a square. The Laplace of hyperbolic function sin h at equal to a by s square minus a square. See, we know that sin h at equal to e raised to 80 minus e raised to minus 80 by 2. Then Laplace of sin h at equal to 1 by 2 out of Laplace of e raised to 80 minus e raised to minus 80. By the linear property of Laplace transform means Laplace of linear transform means a f of t plus b g of t. If a and b are f of t and g of t are two functions, by the linearity of the Laplace transform we can write Laplace of a f of t plus Laplace of b g of t. Okay, that means a into Laplace of f of t plus b into Laplace of g of t. That is the linear property of Laplace transform. Similarly, we can write 1 by 2 out of Laplace of e raised to 80 minus Laplace of e raised to minus 80. Okay, see, we have already proved that Laplace of e raised to 80 means 1 by s minus n. Then Laplace of e raised to minus 80 1 plus s. Take its LCM. 1 by 2 out of s plus a minus s plus a divided by s minus a into s plus a. Okay, we can cut this, cancel this s and s. So 1 by 2 into 2a by s square minus a square. Okay, that is 2 and 2 cancel. Then we can write a divided by s square minus a square. Okay, and Laplace of sin h at equal to a divided by s square minus a square. Okay. Remember, similarly, if they are asking Laplace of cos h at means that result equal to s by s square plus a square. Then what do you do? Instead of sin h at means if sin h at equal to e raised to 80 minus e raised to minus 80 by 2. Then cos h at means e raised to 80 plus e raised to minus 80 by 2. Do like this way, then you get Laplace of cos h at equal to s divided by s square plus a square. Okay. Yes. Do one thing, we can write all this. S divided by s square minus not over plus s divided by s square minus s square. Okay. Laplace of cos h at equal to s divided by s square minus a square. So I write this that formula here. Laplace of cos h at equal to s divided by s square minus s square. Okay. Do one thing, we can write all this formula once again. Okay. I think it will help you for this examination. Tell me one by one. Some important one.
Laplace of 1.
That is. Laplace of 1 equal to
1 by s.
1 by s.
Laplace of e raised to 80
only 1 minute. Then also you have to remember Laplace of e raised to minus 8 equal to Laplace of e raised to minus 8 equal to 1 by s plus a. Next time.
Laplace of t raised to n equal to n factorial by s raised to n plus 1. Laplace of sin a t equal to a by s square plus a square. Laplace of cos a t equal to s by s square plus a square. Laplace of sin h a t equal to a by s square minus a square. Laplace of cos h a t equal to s by s square minus a square.
For doing this some problems connecting about Laplace transform, you have to remember this formula by heart. Laplace of 1 equal to 1 by s, Laplace of e raised to 8 equal to 1 by s minus n, Laplace of e raised to minus 80 1 by s plus n, Laplace of t raised to n factorial by s raised to n plus 1, Laplace of sin a t equal to a divided by s square plus a square, Laplace of cos a t equal to s divided by s square plus a square, Laplace of sin h a t equal to a by s square minus a square, and Laplace of cos h a t equal to s divided by s square minus a square. Laplace of cos h a t equal to s divided by s square minus a square. Okay, then we'll continue next portion next class. Thank you.